Hey, how's it going, everybody? Today we have an amazing problem for you guys, right? It's called guess number higher or lower, right? So it's a very good one. So let's quickly go ahead and read the problem statement, guys, right? Guess number higher or lower. Okay. We are playing a guess game, right? The game is as follows, right? So it's a very fun game. So I pick a number from 1 to n, right? You have to guess which number I picked. Okay, so every time you guess wrong, I will tell you whether the number I picked is higher or lower than you guessed. Okay, so they're gonna give us some kind of information. Nice. Uh, so you call the predefined API and guess, right? Which returns three possible results. -1, you guess is higher than the number I picked. 1, you guess is lower than the number I picked. And 0, your guess is equal to the number I picked. Okay, return the number I picked. Okay, so nice. So now we'll be giving a number n, right, which represents the range of numbers, right, from 1 to n, right? And we have to guess the number that they picked, right? So they're not be giving us this picked variable as well, right? You know, we need to find by calling the API, right, to see what that number is exactly, right? By calling in, we'll call this API, right? Will tell us if it's a 0, right? That means that the number that we sent to the API, right, is the actual number that was picked, right? So that's why we see 6 here, right? So yeah, it's a pretty simple, right? So it's they give us n, right? It's a range of numbers, and we need to guess the right number that they picked before, right? Okay. And by calling API, it's gonna tell us. So -1 tells us the number we sent, right, to API, right, is higher. If it's 1, it's lower. Okay. Interesting. So, the brute force way, right? I mean, the obvious way of doing this, right? What do you mean? I mean, just do a linear loop, right? Well, not gonna overthink it, right? Just straight up, just do a linear loop. Find the first 0, right? Only there's only one 0, right? Anyway, right? So like I was saying, guys, right? We can call the API many times, right? Go from so is 1 the number, is 2 the number, nope. 3 is the number, nope. 3 is the number, nope. 4 is the number, nope. 5, and then we get to 6. That's the number we return. Cool, that's the number that you were looking for, right? So every time we do that, a linear loop from 1 to whatever that number might be, right? So that'll be a linear, right? So a linear solution, right? Which is not bad at all, right? I mean, that's linear fact are normally nice, right? So, but this one's not too good, guys, right? We can kind of do a little bit better, right? Because we can kind of take advantage, right? The range that we're given, right? So because if you think about it, it is a range, right? Because we're starting from 1, and we're going to a particular, right? So we can kind of maybe also take advantage of what they're telling us here, guys, or they're giving us some hints, right? Because it would not have been possible without those hints, right? To kind of improve, right? Those hints are kind of helpful to us, right? And kind of tell us in which part of the array we shouldn't waste our time on, right? Go searching, right? Because let's say we're a particular partition in the array, right? Section in the array, right? Let's say we get a 1, right? Which tells us the number that we picked, right, is lower than the number that was picked, right? So we know that I'm not gonna waste my time searching, uh, waste my time on numbers, right, that are to my left, right? Because the number that I'm pointing at is already smaller than the number that was picked, right? So I must focus my energy on numbers that are on the right side, to my right of me, right? So this is where the partition I'm gonna waste my time on, right? Search that section of the array, right? And then we keep doing it every time, just like likewise. Let's say you get a number, you guess the number where the number was actually higher, right? Right? It's higher. So I'm not gonna continue going up and up and up, right? Searching for more no for the number to my right side. I'm gonna focus on numbers to the left of me, right? So that because that's where it might belong to, right? So right. So you can see that where I'm going with this, right? Is by we need to kind of apply binary search, guys, right? The binary search is gonna help us in not wasting our time and searching the whole array using brute force solution, right? Array is gonna make us efficiently search the uh, number that was picked, right? By asking a series of questions to the API to kind of give us in which part we should focus our energy searching on that, right? Right. So every time we call API, right, we're gonna discard half of the array, right? Which is the beauty of it, guys, right? Which makes it extremely efficient, extremely nice, right? So let's go through a couple of examples, right? So it kind of helps solidify the concept, right? So let me quickly do that real quick. So this is our initial search space, right? So this is our range, right? Because we're giving the number 10, which gives us no, we need to pick a number from 1 to n, right? Which is represents the range, guys, right? Hopefully it makes sense, okay? Um, so now we got our range, right? And we could easily apply better search, right? By just getting the middle element, right? So the middle element is 5, right? We have 5 here, right? We check 5. Is 5 called, we sent 5 to the API, right? And we should be getting a 1, right? Which tells us that the number is lower than the number that was picked, right? So because of that, I'm not gonna worry about numbers to the left of 5, right? Because they all will return the same thing, 1, right? Because they're all lower, right? So I'm not gonna waste my energy there. I'm gonna go to the right. Right, so I'm gonna update the pointer, so now our search space is here, right? We do another binary search, we get 8, right? Somehow, and 8, right? We check is a greater, right? So we'll get a -1, right? So our search space becomes here, right? And we can see 0, right? And then zeros are, middle element because that's our search space here, right? A 6 is our middle element, we send it, right? And then we get a 0, and then that tells us, boom, that is our number that we're looking for, and we're returning, right? You see how we did this in way fewer comparison iterations, right? Than the brute force linear loop, right? See how by wasting our time in certain section of the array, right? We can just cut the search space in half every time, right? That's the beauty of the binary search, guys, right? That's the kind of the takeaway here for you guys to get. The binary way can help us search efficiently, in which we have some kind of a range of kind of search space to, worry about, right? So let's quickly go into the code. Hopefully everything kind of makes sense, right? So in left equals 0, right? 1 initially. And the right boundary is, n, right? Because that's our upper bound. And we have a while loop here. Standard template that we have here, guys, right? And we calculate our midpoints. So we have our middle element here, guys, right? So what's next for us is to make decisions on whether to go left or right. So we guess, right? So if so one thing I'm gonna do here, right? I'm gonna do a check here as well before I go left or right. If the guess, the middle element that I'm pointing at, right, equals to 0, simply return that number, right? So that tells us that's the number that was picked, right? Because that's 0, right? So now, if a number, right? So we commit, right? If a number is lower, right, than that was picked, right? Which just tells us that if it's a negative, if it's a 1, right? Then we update our left border to be mid plus 1, right? Because we're gonna go to the right, right? This is why we do this. And if it's the other way around, if it's greater, right? If it's greater, then we go to the left, right? We're updating the bounds here, okay? And we returned a -1, right? If we never found that number, right? Which shouldn't be the case. Let's press run code. Looks good so far. Like it. And yeah, so we said that our initial search space is 1 to n, right? And we just apply better search. If we find a number, we return that number. If we get, so now if it's not a number, right, we get the other case where if the number is smaller, right, then the number that was picked, right, we go to the right because we want a bigger number, right, because the middle element is smaller, right? And yeah, looks good. So, all right, perfect, guys. We were past all the test cases, guys. So I want to thank you guys for taking the time to watch the video. If you guys found value, make sure to give me a like. If you're new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.